This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. 2.5 Admins, episode 260. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, your customary plug, Alan, is ZFS Summer Roundup, smart hardware advice.
Yeah. Over the summer, we don't write quite as many articles since everybody's on vacation, but we've prepared a little roundup of some of the articles we've done in the past on the topic of, managing, selecting, and monitoring your hardware. And it's got a lot of good advice on getting the right hardware, making sure it works, and finding out when it doesn't.
Right, well, link in the show notes as usual. Michael at Phoronix has been doing some testing of the relatively new AMD Ryzen AI Max Plus 395 versus a Ryzen 9 9950X and a 9950X3D. And something jumped out at you, Jim, from the results.
Yeah, I have to admit, I'd been sleeping on this hardware. I had not paid any attention to AMD's AI Max line. It just didn't sound like anything I would care much about. But when I saw that Michael was comparing it to the heaviest duty consumer desktop processors, I was like, okay, well maybe that's worth a look. And the surprising thing was not that the AI Max 395 Plus Pro whatever super whammadine thing. The surprise wasn't that it smokes, the big desktop processors on AI workloads. Yes, it does smoke them on AI workloads. No, that's not a surprise. What surprised me is that this little bitty laptop level power consumption processor, it hit better than 80% of the performance of the 9950X3D on every workload. It averaged something like 95% of its performance across all the workloads that Laravel tested. And if you're familiar with Phoronix, you know that when he tests a processor, basically he throws every benchmark you can find under the sun at it. Unfortunately, you don't get a lot of commentary on what each benchmark really does or does not mean. You don't get a whole lot of useful analysis. But the fact that you get every single benchmark does give you an idea of whether there are any weaknesses somewhere in a processor's performance level, because if there is, well, it's at least in one of those benchmarks that Michael throws at, even if you don't know which one. So when I see this little teeny tiny small form factor processor that goes in laptops and little palm size mini PCs hanging with a 9950X3D, even on server workloads, and at less than half the power consumption, typically, it gets my attention.
Yeah, at first I wasn't overly impressed seeing, the frames per second or the time to compile. The AI Max was reasonable, but didn't really stack up against the 9950. But then after each of those, you see the, joules per whatever. And it's like, oh, so it was a bit slower, but it did it with half as much power. That is definitely interesting.
And that means, it's not just half the power. If you're in a warm climate, that also means, half the heat load that you have to worry about, air conditioning out of your own space. It means, half the fan noise with the same amount of cooling equipment. Like, there are a lot of benefits to running lower and slower. And anybody who lived through the AMD pile driver era ought to be pretty familiar with this, because back then, if you were a staunch AMD fan, as I tried to be, pile driver was it was the pile driver that broke the camel's back for me. I had been putting up with lower performing AMD processors for quite some time, making myself feel better about thinking whether or not they had a truly higher core count than their Intel counterparts, despite the higher power consumption and the lower performance on a lot of workloads. But it was that power consumption that really killed it. It's really hard to justify putting a machine in front of a client, for example, that's just running fans at, like drill press mode all day long and isn't particularly fast when they see an Intel system right next to it that's whisper quiet and does the same thing. Of course, that was then, this is now, and AMD is doing to Intel very much what Intel once did is in terms of performance per watt, even on the regular desktop stuff. So when I see this processor trouncing AMD's Ryzen 9 on performance per watt, knowing what that's already doing to the Intel stuff, at this point, really our comparison is not so much Intel as Apple Silicon. We're in the performance per watt territory of, Apple's best M4 silicon, and we didn't even have to go ARM for it. Did you ever think that we would see ARM level performance per watt on x86, Alan?
No, I really was not expecting that.
Me either. This is why I wanted to cover it on the show. It's just, it takes a minute for that to sink in. That as much as the Apple M series, their native silicon has been the darling of the industry ever since the M1. And I'm not saying it's not deserved. That was a groundbreaking design. And it had me thinking, well, that's ultimately the end of x86 because we're never going to get that power efficient. But a few years later, here we are. And by the way, if the AI Max 395 Pro Plus or whatever is a bit too much of a mouthful, you have a different, not entirely great branding choice because they are now referred to as the Halo Strix line of processors, which is maybe a little easier to say and remember, but just makes everything sound like a game console.
Yeah. Yeah, it really goes to show the value of not having a monoculture, right? Like when AMD came and trounced Intel, it was a big deal that suddenly when there was competition, Intel had to improve. But, we see the same thing here with just different platforms. x86 dominated for so long, and then ARM actually got serious. And, you saw with the Amperes and the M3s and so on. And suddenly, when they put their mind to it, the x86 CPU can get down to those kind of power numbers suddenly.
It does make you wonder if we would have actually seen something like the Halo Strix out of AMD without Apple's native silicon to push back against. Would they have gone that far with this if all they had to fight was Intel, who, they were already kicking their butt?
Yeah. You also had Microsoft going with the Qualcomm ARM processors, their AI things they tried to do with the recall feature and all that. So I don't know if it was all because of Apple, but it does seem like that was really the catalyst that got all this stuff going. Although if we could name the CPUs not to put AI in the name, that'd be great.
That's a very valid point that, a lot of this could be Microsoft driving it because they need something to power their horrible Recall Plus nonsense on x86 and compete with Apple Silicon. And I don't think Apple's really going to be interested in selling a lot of M4 to Microsoft to build Surface stuff with. So even still, even if you say that Microsoft was the one who drove that, the fact that Microsoft can't get presumably Apple native silicon still kind of, I don't know that we've pushed the can that far down the road from like it's really competition with Apple. I think that very likely drove this level of development from AMD.
Well, and hopefully this will drive innovation at Apple.
Absolutely. I mean, Apple's been doing a pretty good job of iterating on their native silicon stuff all by their own. And anybody who knows me knows I'm not an Apple fan. I haven't been since, Woz was the Steve that mattered. But credit where credit is due. That is a great hardware line. And it's Apple native all the way. They did a hell of a job. They shook up the industry. But yeah, I am definitely happy to see some real, no kidding competition. And the fact that we didn't even have to leave the x86 architecture to get it is one hell of a bonus.
Yeah, but I think the point I was trying to make is just it turns out having competition and having not a monoculture is important. And that goes at all the layers of the stack. Obviously, we're talking about the hardware right now, but the same thing goes for operating systems, right? We need to have choices. Otherwise, we're going to have, one thing that stays the same. The same thing goes all the way up to stack. It's why it's important that we have more web browsers than just Chrome, and we have more operating systems than just Linux, and we have more hardware than just x86.
UK government says delete old emails to save water.
Now, to be fair to the UK government, this was a throwaway line in an otherwise innocuous, kind of pat yourself on the back. Hey, Britons, we've been conserving water and we should feel good about that. Let's keep conserving water. And, there's just one line in a sentence about, by doing things like turning off the tap when you're done or deleting all emails. And the reason that this is worth covering, other than laughing at Joe's government, which is worthwhile on its own, is I think just to point out that you always kind of need to take anything that you hear about tech particularly from any mainstream source, with a big fat grain of salt, because people will very confidently tell you tech things that are absolutely wrong. They don't know the first thing about, but they think that they do. Like, for example, the idea that deleting an email will somehow save water.
Yeah, so the actual line is delete old emails and pictures as data centers require vast amounts of water to cool their systems, which depends on the data center. I know plenty that don't use water, but that's not untrue. But especially with old emails and pictures, you may actually cause more processing to happen by dredging up an old thing and doing a bunch of processing on it to delete it than you would by just leaving it there.
Yeah, there's no may about it. You absolutely will generate more heat by asking it to delete that file than you will by the file just existing in the first place. The advice, if you're going to somehow tie this to email, which is weird, let me be clear, would be to send less email. But even that, I mean, you don't really get to take that on yourself because fewer than 3% of all email sent is sent by actual humans. So if you're not a spammer, your use of email is not the problem in terms of water consumption, of all things. Stop using AI agents to parse all of your email. That'll help.
Well, yeah, I found a headline from June this year. Government to invest over £2 billion in the UK's AI ecosystem.
Yeah, don't do that. And that'll save water. If you're not familiar, what we're getting at here is that AI is extremely compute heavy. And when you hear a government saying that they're investing many billions of dollars in new AI data centers, what you should also be hearing is, holy crap, that is a whole lot of extra stuff that we're adding to the power grid and a whole lot of extra water that we're going to need for cooling all that nonsense. Because you will, because AI, again, is pretty much the most CPU intensive workload there is.
Well, compute intensive, let's be clear about that.
Sure, compute intensive, correct.
I think the biggest problem with deleting emails and pictures to save data center power is that deleting some files isn't going to make the data center turn off any hard drives. They're spinning either way. So yeah, you're most likely to do more harm than good trying to delete old emails in order to save water. You know, you can delete old emails for plenty of other reasons, and those are fine, but you'll do a lot more by taking a shorter shower than deleting a bunch of emails.
Realistically, the most water usage efficient way to destroy your old emails is to just wait till you die. They'll get rid of it with your account eventually once you're gone, and it won't require any extra cycles at that point to do it. So if for some reason that's your thing, is you want your use of email to consume the least water possible, the first thing is make sure you're not using any AI agents in the cloud to manage your email. And then trailing way past beyond that is don't delete any email. Just die.
Maybe we could somehow swing this to be like, spam is using up all the water. We must stop the spam.
Well, what annoyed me about this was that, as usual, it's the government trying to put it on individuals to do something about environmental issues, when really we need governments to act and bring in regulations and legislation.
Yeah, control who's using the water and what they're allowed to use it for, rather than telling people that they should take shorter showers.
Yeah, and not build massive fucking data centers just for AI bullshit.
Well, you're certainly preaching to the choir in here, and I suspect we mostly are to our audience.
I'm still annoyed, though. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Another perk of being a patron is you get to skip the queue, which is what Toby has done. Toby writes, if I have a laptop with ZFS en route, for example FreeBSD, but it's not encrypted, and I would like to have something like verified boot, can I do a snapshot after installation? Then every time I boot, check if anything has been changed since the last snapshot to detect tampering. For upgrades, I could make sure nothing changed since the last snapshot, or roll back to be sure, then apply updates, then snapshot again. Could this be defeated with careful block-level editing by the malicious actor?
So to get something like verified boot, you can do what you were talking about with snapshots. In fact, I built something like this for a company. We called it kind of like kiosk mode, where we taught the FreeBSD bootloader to be able to boot from a snapshot, not from a file system. So you install the system and make a snapshot, and if you boot from that, any changes you made to the system won't be visible to the bootloader. And so with that, they basically had a machine that would just forget everything you did every time you reboot it, because it would revert back to that snapshot every time you reboot it. And so you can do that to have a machine where, if you know that snapshot is right, then you can ensure you don't get anything else. And we built an extended feature of that where you could enforce via the BIOS that this particular snapshot is the one that gets loaded, not just any snapshot. So you could actually make this machine impossible to get it to boot some other software than the one you wanted. But for your case, the easiest part is that if you just have the snapshot and then you boot up, if you use the ZFS diff command against that snapshot, ZFS will actually print out a list of everything that's changed in that data set since that snapshot. So you'd be able to just quickly tell, have any files changed? And if so, which ones in what way? So it'll say, hey, this file's been deleted, this file's been created, and this file's been modified. And you can use that to tell if anything has changed and decide if you need to roll back or not. And it would give you most of what you're looking for, kind of a tripwire style intrusion detection. So tripwire is an old style intrusion detection system. It basically worked by when your system's in a known good state, you run tripwire and it basically takes the SHA-256 sum of every file on your system. And then later you can run it again and tell if any files have been changed and, especially when they weren't expected to be. And so the ZFS diff is giving you kind of the same thing. And in fact, the FreeBSD update tool has a mode where you literally run FreeBSD-update IDS, and it will check the SHA-256 of every file in the system, all the system files anyway, not the configuration files, but the actual binaries and libraries, to verify that none of those are different than they're expected to be. So that you can get a lot of the way with that, although it is not the same thing as using secure boot and making sure that, you don't execute any code that's not signed. But you can get a lot of the way there and especially be able to detect things without all the other rigmarole that goes into trying to get the whole secure boot stack.
One of the larger challenges with this type of security initiative, whether it's, old school using tripwire or whether it's what you're trying to do with ZFS snapshots, and maybe using ZFS diff to detect when files have changed, is that standard distributions, they're kind of a dog's breakfast when it comes to the file system. There are temporary files getting written all over the place in places that you might think, well, nothing should be changing here, so I shouldn't be looking for changes to happen. But when you actually monitor the file system, you discover that it's making changes all the time. You also have to worry about, if you're doing this and, it's going to raise alarms for you anytime that these files get modified, you need to be really aware of when you run an update. You can't any longer really just let unattended upgrades do its thing and, expect to carry on about your business, because that means that you're constantly going to have unexpected changes to the file system. What you might want to look at doing instead, if this is something you're really interested in, honestly, this is what immutable distributions are all about. If you look at something like, Silverblue on Fedora, with ZFS for that matter, you get a properly immutable file system that gives you a lot more of what you're looking for in terms of those ready assurances that some third party hasn't mucked around in files that they shouldn't be able to.
Yeah, and that actually raises the point that if you've laid out your ZFS datasets in the right way, you could make the files you're worried about them modifying, like the root file system and /boot and so on, actually read-only in ZFS so that they can't ever be changed. Or they can't be changed unless you purposely ZFS set read-only equals off on that dataset. And that would allow you to automatically refuse to allow any changes to those files while still having your home directory be writable so that, your web browser will work and so on. And still have /tmp as a separate ZFS file system that is writable and so on. As to your point about could this be defeated with careful block level editing, that's one of the things about ZFS is because, you have a data block that sure somebody could block level edit, but the checksum for that data block doesn't live in that data block. It lives in the indirect block that then points to that data block. And so there's no way to go backwards. So if you edit a specific data block, if you're looking at a specific data block, you can't tell which metadata block is the one that actually points to it. You have to start at the top of the tree, the meta object set, and traverse down through the indirection. And the parent is the thing that has a checksum of each child. So that's how ZFS ensures that it doesn't decode the data and try to interpret a block as a ZFS block pointer unless the checksum matches, and that keeps it from crashing when it encounters garbage data. But it means in order to edit one block in one file, you'd have to edit the top level block and then every block along the path to get there. So you'd have to edit dozens of blocks just to be able to change one block and have the checksum show up as the right thing. And you'd have to recalculate all the checksums all the way as doing that. And so it gets much more involved than just carefully editing one or two blocks.
And to be clear, yes, you could do that, but it's such a giant pain in the butt. It's very difficult to imagine anybody bothering to go through all that trouble to do that sort of like recursive all the way back to the root editing just to make like their little thing. Like if they've got the resources to do all that, they've probably got the resources to screw you over a lot more efficiently and get better results out of it, 10 different ways. And finally, what defeats that is, well, if you're doing replication to, another target somewhere else and they do the kind of block level editing we're talking about, that'll break your replication chain. So you're going to discover really quickly that things don't work right anymore because the checksums on the source no longer match the checksums on the target, and you wind up with issues there, and that's going to be your canary in the coal mine. So yeah, I mean, given sufficient computing resources, anything in computers is possible, but is casual block level editing on ZFS something that you practically need to worry about? No, it is not.
Dennis, who's a patron, also skipped the queue. I'm planning to run some VMs on a Linux host using libvirt. For the storage backend, I'm planning to use ZFS. So my question is, how should I use ZFS with libvirt? Should I use zvols, or should I have a ZFS dataset with QCOW2 or RAW? The OpenZFS docs recommend zvols or RAW files to avoid unnecessary overhead, but Jim warns zvols significantly underperform both RAW files and QCOW2 files. Can Jim and Alan go a little deeper into this zvols significantly underperform? Also, are there any performance hits to using QCOW2 because of nested copy on write? I'm currently just looking for the best general purpose out-of-the-box experience.
Okay, so the short answer is if you want maximum performance, you do not want to use zvols or QCOW2 files. You want to use raw files on a dataset, and that dataset should have record size tuned appropriately for the workload. As far as the question of performance hits with QCOW2, essentially you get roughly a 50% performance hit on a sparse QCOW2, one that is nowhere near fully allocated yet. The closer that QCOW2 file gets to fully allocated as you actually make changes to that virtual drive, the closer the performance gets to what you would see on a raw file. Please don't ask me to explain the workings of that because frankly, I don't understand them and I haven't tried. What I know is I have tested the absolute crap out of it, and an empty QCOW2, like I said, pretty much 50% across the board as compared to raw, but by the time it's full, you can still measure a performance hit, but I mean, it's on the order of like 2 or 3%. It's nothing. So if you're going to pretty rapidly fill up your drive, then there's not a whole lot of difference between QCOW2 and raw. But if you are just allocating like a standard drive that you're not looking to get full very rapidly, you just kind of want stable, predictable performance over a long period of time without a whole lot of changes, then yeah, you probably want a raw file. Now, as far as the performance issues with zvols, when I said the QCOW2 files were roughly half the performance of raw files when they're empty, the performance penalty that we see from zvols ranges from about half to roughly 8 times slower, depending on which type of workload, whether you're talking about large blocks, 1 meg, or small blocks all the way down to 4K. The smaller the block size, the worse the performance penalty gets for using zvols instead of datasets.
Especially on Linux, because Linux exposes zvols as block devices rather than character devices like on FreeBSD. The Linux buffer cache gets in there, and then you end up double caching stuff, and it does prefetch at the kernel level separate from ZFS, and it does a bunch of things that really make it not work as well. The ZFS community is working on improving that, and the zvols aren't as bad as they used to be, and there's active work to make them better. But for now, I think Jim's advice and the documentation of create a separate data set that can be tuned specifically for the raw files and store raw files there is definitely the best way to go. And if you're doing it with libvirt and so on and having a separate data set for each VM is really nice to be able to have different replication and snapshot policies per VM than just having one giant data set with all your VMs in it.
And finally, since Dennis said that he's currently looking for just the best general purpose out of the box performance, for that use case, I would recommend a record size of 64K on your data set that contains your raw file, or even QCOW2 if you decide to go there. I know it sounds like a lot to say something is only 50% the performance, but you need to understand that when we're talking about a delta, whether it's in storage or CPU, with most workloads, that's not really the big metric that makes the impact. It's about latency, not throughput, for the vast majority of it. And you don't have a huge latency penalty with the QCOW2. regardless, the point is, if it's just general purpose VM and general purpose performance, you want to set record size to 64K.
Yeah, the advantage of that is compared to really small block size, you're going to have a lot less overhead and fewer indirect blocks and less amplification. And the bigger size also allows ZFS compression to do more for you. And if your VM tends to be compressible, especially when it has Spark splits and so on, it can really make a difference in the amount you can cache because ZFS is going to cache the compressed version. And so you're going to get that much more out of it all.
And in general, for generic workloads, and especially desktop type workloads, the majority of your storage workload tends to be closer to 64K block size than pretty much anything else. So 64K just winds up being pretty much the best. Again, it's a rule of thumb. There are different workloads, especially if you're working with databases. It's definitely different. You're going to want typically smaller block sizes. If you're only doing like a file share, you're just dumping your watchable Linux ISOs in a big directory and sharing them with the rest of the network, ideally you'll want a larger record size for those. You'll want a record size of 1 meg. 64K is just kind of that sweet spot of this is a general purpose VM doing general purpose stuff. It might have to run a database. It might be sharing or downloading and saving, very large files. We don't really know. And when that's the case, 64K is that sweet spot that doesn't penalize you too much on throughput when you're working with large files, or too much on latency when you're just clicking something on a desktop and expecting to get immediate results when you do.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at jarrest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Alan Jude.
We'll see you next week.